everyone, my name is Lisa Tian.
My name is Kitty.
My name is Amy.
And my name is Elaine.
Today we are going to answer one big question. How does the gravity shape matter and light in the university? You may wonder why planets about the stars or how stars from all of this about gravity and space-time. Let's use our gravity well model to show you the science behind it.
First, let's talk about our model. This stretched spandex is the space-time, the cosmic fabric that holds everything in the universe. And these marbles, they are small space like planets or even light. This heavy steel ball is the black hole and a star that's the large mass. And this light rubble ball is a small mass like Earth. And every part of the model stands for a real thing in the space.
Now let's see the space-time curvature in action. When I put the heavy steel ball in the spandex, it makes a deep white curve, and the rubber ball only makes a shallow curve. This is the key. More mass creates more curvature, and more curvature means stronger gravity. That's how mass warps space-time in the real universe.
Now let's check how curvature affects motion. In flat space-time, marble rolls straight, but near the steel ball, the marble follows the curved spandex. It doesn't move straight at all. If I roll it at the right speed, it warps the steel ball. This is actually how planets orbit stars. They follow the curved space-time created by the star's mass. That's gravity at work.
Now let's simulate star motions. No central mass here, just like the earlier universe. When I relieve this matte ball and small steel ball, they don't stay spread out. They move toward each other and squash together. Why? Because gravity pulls all small mass together. Over the time, these clusters become density enough to form stars. That's how stars are born from the combined matter.
Okay, so our model shows the basic, and our display board will explain more. Section A about the gravity and the space-time. It's all about how mass curves the cosmic fabric, just like our spandex. Section B, the redshift and the expanding universe. And our section C talk about the black hole, and section D is how gravity bends light near black holes. All these ideas tie back in why force of the gravity.
Let's use the slinky to model the redshift. The slinky represents the light waves, which have the certain wavelengths. When I stretch this slinky, the waves get longer. In the universe, when space expands, light waves stretch too. Their wavelengths get longer, and that's the redshift. We can see this with distant black galaxies. Now let's tell the difference between the two types of the redshift: expansion redshift and gravitational redshift. Expansion redshift is when light waves stretch because the universe is expanding. This is what we can see with faraway galaxies. Gravitational redshift is when stronger gravity stretches light waves. One is from expanding space, the other is from strong curvature and gravity. That is the key difference.
So, how does gravity influence matter and light in the universe? Let's sum it up. Gravity comes from mass curving space-time. It pulls matter together to form stars and planets, and it makes objects move in curved spaces, like planets orbiting stars. For light, gravity bends its path and can stretch its wavelengths to create gravitational redshift, while expansion redshift comes from the universe growth. Gravity is the force that shapes everything we see in the cosmos. Thanks for watching.